Good morning or afternoon, depending when you're looking at this. I wanted to go through this kind of instructions on how to do this project to make sure you understand it. These links have been fixed, so I'm just going to go through and explain the activity itself first of all. So when it loads eventually. So this is going to be an application grade. Um, and I'll talk about how I'm going to grade it in a minute. So we learned about the different types of electromagnetic waves and what makes them different from one another. We're going to work to prepare a presentation that explains some of the key concepts you have learned. You're going to be editing a slide presentation that talks about the various types of electromagnetic waves and talks about how they're used, how the dangers are, and you get some pictures and a video of each. I'm going to kind of show you how to do these. Now, for the grading itself, there will be 3 slides basically for each of the 7 ranges of the electromagnetic spectrum. So the first one's going to be an explanation of what the type of wave is, the range of the wavelength, so how long it is, and an image that represents one of the concepts from the slide. Second slide of that wavelength will be an explanation of the uses of it, the dangers of it, and again, an image that represents the concepts. And then finally, each one is going to have a video. I'm going to show you how to edit that as well. Now, one thing for this project now is this, before I move on, you see that each slide, so there's 3 points for this slide, 3 points for this slide, 2 points for the next slide. So all of those for each range, there are 8 points. Well, it takes 7 ranges times 8 points. You get 56. I'm going to divide that in half. So this will be a 28-point application assignment. I will definitely give you all of Monday. I may give you all of Tuesday as well, depending on how things are working out. Now, in terms of information, this link right here is a really great use of a resource because it has all the information that you need. You can probably do this entire thing without leaving this page because it talks about how radio waves are made. It talks how they are used. It talks about their wavelength. It talks about their dangers. Okay. Now it also gives you some pictures. You cannot copy and paste these pictures from this resource, but it gives you an idea of some pictures to use. And then when you get to the next slide, you go to microwave, and it has, again, the same information, how they're made, what are their uses. So all the information you're going to need is right here. So what I want to explain now is how this is going to work. Is you're going to open up this link, pardon me, and you cannot edit this. I don't want you to edit this. Every person is going to be working on their own activity. It's 22 slides. Yes, it is. But the information is extremely straightforward. So let this load for a second. Now, so the first thing you're going to do is you're going to file, because you cannot edit this, make a copy. I can edit this because I own it, but yours is going to look a little different. And then what you'd probably do is your name, slides. So something that recognizes your name and that it's you. And then go ahead and click OK, and it's going to create a brand new document. Now, this document you have full access to. You can edit it, but the template is there for you to use to help your life a little easier. So again, this is a copy that comes up. I can see my original. I can close that one if I want. I'm not going to need that anymore. Then, once it loads, pardon me. So once it loads, I can go ahead and start editing. And here I would put my name because this is going to be my copy. So you put your name of your spectrum, of your presentation, sorry. Now, with each one, they have a space for an image, how they're made, wavelengths, relative size, uses, dangers, and then a video. And I'm going to explain how to get all those things in a second. So, uses and how they're made. So if I go back to that tab I opened, go to radio waves, it's the first tab, how they're made. They are made by given off by stars, sparks, made by transmitters. So what I could do is click on the text box. And I do not want you to copy and paste. I want you to type. So radio waves off by stars or by antenna. And I'm going to be spelling that wrong, but that's fine. Okay. So that's all I need. I don't need a tremendous amount of information for there. Wavelength size. Pardon me. They break radio waves a little bit differently. I'm not a big fan of the way they can be down to 30 centimeters, and we can see they go down to like a 1 to 2 kilometers. So the range they give is about 100 meters to about 1 to 2 kilometers. So if that's what you were going to use, I would say 100 meters to 1 to 2 kilometers. Yeah, I should probably use. All right. If I wanted to find an image, okay, so we talked about radio antenna, so I can just go to Google and type in radio antenna. I go to images. Okay, so let's say I like this one because this explains what's going on. I can use a GIF if I want, but I'm going to go ahead. I find it's easier on Google to click on the tab and have it open here. Now, if I have a mouse, I can right click. If I don't have a mouse, I kind of put my finger on and hold it until the menu pops up. It's a lot easier to copy image address. It's going to save basically the URL code, the Uniform Resource Locator code for this picture. So I go to my presentation. This is where I want my image. So Mr. Yankee already put a box here. If I go ahead and just click on the box and backspace, it makes it go away. So I want to insert an image, and I copied by URL, so I'm going to insert by URL. Here's where it gets tricky. Sometimes they don't always work, but if I paste and it gives me my preview, I can go ahead and insert that in. Once it's inserted, I can crop it to make sure it fits where I want it. Boom, I have my picture for my image. Okay, uses. Go down here. What are the uses of radio? For police communication, television transmission, so I could type this in the next box. Then dangers. Also here, large doses can cause cancer, leukemia, other disorders. Okay, so this is just one resource. You can look anywhere else. You can just do a general Google search if you wanted to. But that's where I put uses and dangers. Now, the last thing you're going to do is find a video. Now, I don't want a whole video, but I am going to go to YouTube. And everything seems to be running slow today, so I do apologize for that. And I'm going to go radio waves, because that's what we're talking about. And I want it less than a minute, so if I can find one that's actually less than a minute to start with, that's fantastic. I'll click on that one. All right, so this is got a lot of information. The less than a minute's a lie because I don't have one. So if I have this radio waves, and there's tons of videos you can search for. I can watch a video until it has the information that I want to present. I want less than a minute.
At the speed of light. They passed Sirius in 1903.
So I don't find this stuff very helpful.
And Regulus in 1971.
So
that signal has already passed over 1,000 stars.
So I wouldn't want to include this stuff just yet.
Those stars, with a really good receiver, could detect Marconi's signal and know that we are here. Radio waves are the longest and contain...
All right, so this is the kind of information I want. This started around 40.
While visible light is measured in minute fractions of an inch, radio waves vary from about 19 centimeters, about the length of a water bottle, to waves the length of cars, ships, mountains, all the way up to monstrous waves longer than the diameter of our planet. Heinrich Hertz.
All right, so that was like from 40 to 103. So if that's the part that I want of that video. So I need to copy the top link. Go back to my presentation. I know it's probably going to be tricky at first, but once you get in the habit of doing it, it's basically just copy, click, paste, a little bit of typing along the way. This is being very temperamental all day, driving me crazy. All right, so I want to insert a video this time. Now I copied and pasted this link, so I copied this link, so now I'm going to paste it. And then I'm going to search. I'm going to say, okay, here's the video I want. And I hit select, and it's going to insert that video. Now, again, I don't want that entire video. So what you're going to see open under my head here, I'll move my head a little bit if I need to. There we go. Is I only wanted from the video that started around the 40-second mark and went to about 1:03. I don't need long parts of the video. Once I have that, and you can have it play on click, you can have it play automatically, either one if you want. When that's done, there's nothing to fix here, nothing to finalize. You just go ahead and click off of it, and it will save that. So now when I play this video portion, it starts at the 40-second mark,
waves are the longest and contain the least energy,
and it will go to my minute 3 mark, to my end point. So you decide where the beginning and the end point is. Please no longer than a minute, but that's my video. Now, I'm going to go ahead and stop this so it's not two people talking at once. So I'm going to go ahead and do the exact same thing for microwaves. So I can go back to here. I want to go microwaves now. All right, how are they made? Well, they're made by transmitters. Okay, fine. What are their wavelengths? If you need to find wavelengths as well, relative size, you can always go pull up the spectrum on a different tab or a different image. Pardon me. And on this image, it tells you what the relative size is. So if I clicked on this link, and eventually it loaded. So this is Wiki, which I'm not a big fan of, but if I wanted wavelengths and stuff, they're all here. But that's not exactly the one I wanted to use. So let me try and get. I didn't realize it was a Wiki site. Yeah, so this one has it. You have to find one that has it. So here, a radio wave is about the wavelength, relative sizes of a building. For a microwave, relative size are humans. Infrared, we're talking relative size between a butterfly and the eye of a needle. And then we're talking about bacteria. So there are lots of different electromagnetic spectrums that show relative size of the waves. Just got to find the right one. It's also in my notes that we went through. So there's how to enter videos. There's how to enter pictures. How to enter information. Again, you'll have you'll have the next 2 days of class to work on this as well. And then when you are done, you're going to share. This is a copy, so only your name will be on it. Mine wouldn't be on it. And you're going to send it to srainey@d118.org. So you're going to share it with me. I'll get an email saying I got it, and I will be grading it over the next few days. It is an application grade, and I will be grading it over the next few days because you have the next few days to work on it. But you will have all class time. If you have questions about how to install stuff, please ask. This video should be a good explanation of how to do the shifting and the connections. But if you have any questions, you can ask in class or during study hall. I'd be happy to help you. Hope this explains what you need to do. Good luck, and I look forward to looking through your presentations.